All right, students, welcome back. And this is part 3 of solutions. And today we're again going to be focusing on measures of concentration. The other day we got introduced to what are measures of concentration and our first actual calculation in terms of measures of concentration, and that was percent by mass. And just to quickly review, a reminder that when you're dealing with a solution, when you're measuring the concentration, there's several different ways you can do it, and we're going to learn some more ways today. But basically what you're determining is the amount of solute you have compared to the amount of solution, or in some cases you might be comparing solute to the amount of solvent. And the more solute you have, the more concentrated the solution is. And the less solute you have, the more diluted the solution is. So that's what we're basically trying to express in a mathematical terms, is how concentrated. Sometimes we might think of it as how strong something is, in a manner of speaking. So the other day we did percent by mass, and we said that that one was pretty simple. It's like percent of anything. You have the part divided by the whole, and the part would be the solute divided by the whole, which is the solution. So you have your mass of your solute divided by your mass of solution. And that's kind of how you figure out your percent by mass. Today we're going to be introduced to the most commonly used one, and it kind of goes by an odd name, or at least you might think it's funny. And so the second one is what we call molarity. And molarity is represented by a capital M. So anytime you use the unit for molarity, it will be a capital M, and often it's written kind of in italicized. So that will be what the unit for molarity is. And the formula is basically molarity equals moles of solute divided by liters of solution. And you have to pay attention to the units. This is very important. You may or may not always be given moles of solute. You might be given grams of solute, in which case you would have to convert from grams into moles. But you guys are already experts at that and know how to do that, so it shouldn't be any trouble for you. And then you'll notice on bottom it's liters of solution. But in a lab type situation, often we don't use liters, we use milliliters. We measure things out in our beakers or in a graduated cylinder, often in milliliters. And so often you will be told the milliliters of solution instead of liters, and so you have to convert from milliliters to liters, which is easy, just a reminder in terms of dealing with our metric units there. To convert from milliliters to liters, you would simply divide your milliliters by 1,000 to come up with the right answer there. So before you plug those numbers into, you just need to make sure you actually are in the correct units. So we're going to do some examples of that here in just a minute. So let's take a look at this problem here. It says, what is the molarity of a solution that contains 3.4 moles of solute in 245 milliliters of solution? So at least at the beginning here, they give us moles of solute, and we're going to plug that in just a second. And we're going to look for liters of solution. Remember, that's our equation, and that's always the first thing you want to write down, is write down your equation, the formula that you have. So before you plug any numbers in, write this down so that you can visibly see what is it I need to know. And remember, in these measures of concentration, there's always going to be 3 things, and 2 of them you will be provided with information to find. And so you just have to figure out what are the 2 that I know, and which is the one that I'm looking for. In this case, it says what is the molarity of a solution, and so you're comparing the moles of solute to the liters of solution. Well, in this case, they give you moles of solute, so you can go ahead and plug that in. 3.4, you don't need to convert it, just boom, plug it right in. That's easy. Now on the second step here, I do have to do a little bit of work, and that is, it tells me right here that I have 245 milliliters, and you'll notice that milliliters is not the same as liters. So we're going to have to convert. And so I'm going to take my 245 here. And we won't do this every time, but I want to show you the first time. And you have milliliters. Oh, that's a nasty L. Oh well. And we're going to convert that. So anytime we convert, we multiply by a fraction. We're going to put milliliters on the bottom here so that they cancel out. And then we're going to put liters at the top. Liters is the larger, so liters is 1. In 1 liter, how many milliliters are there? There's 1,000. And then, so basically, 245 times 1 is 245 divided by 1,000. And so we can come over here and write 0.245 liters of solution. So that's where we got that 0.245, is by converting our milliliters into liters. And anytime you have milliliters and you're converting into liters, you're always going to divide by 1,000. Just a reminder from back at the beginning of the year. And then once you have your numbers plugged in, you can go ahead and do your math from there. And that should be pretty simple. And you should end up with an answer of, in this case, if we were to write our equal sign here, that equals 13.88. And remember, we want to go out to the nearest hundredth in this case. And this is the unit I would use. You have, it's moles over liters, or moles per liter, or we express that as molarity, or capital M would be how I do that. So 13.88 molar solution would be the answer. And that is a, at this point in time, you're probably not, well, is that a strong solution? Is that a concentrated solution? Is that a diluted solution? I don't know. I will say this, generally speaking, when you get over 1, as you're starting to get into larger numbers, 2, 3, 4, 5, especially as you get, above 5, 10, 13 is definitely a strong molar solution. The strongest hydrochloric acid we have in the, just to kind of give you an example, when we use acids, the strongest hydrochloric acid we have in the back room there is a 12 molar solution, and you definitely don't want to play around with that. That's pretty potent stuff there. So that would kind of give you an idea of the concentration here, just something that you might be familiar with. All right, let's take a look at another one here. Now in this case, I changed it up a little bit. We have the promises. What is the molarity of a substance which has 13 grams of NaCl dissolved in 300 milliliters of solution? So again, the first thing that you want to do is write your formula, write your equation. So we did that. And then I'm going to plug in some things. Now, first of all, I'm not told my moles here. So you'll notice that I don't know what my moles of solute are. So before I can plug it in, I have to figure it out. In this case, I'm told I have 13 what? Grams. Uh-oh. We have to convert from grams into moles. But again, you guys are experts at this by now, so it's not an issue. So I have 13 grams. I want to get out of grams and into moles. And so I'm going to multiply by a fraction, put grams on bottom, and put moles up top. And whenever we're doing this, remember 1 mole, how many grams are there? You go to the periodic table. I have sodium chloride, which is, I believe, 58.44. If we were to add that up, and again, it helps if you're following along with your periodic table. And so if we did our math there, we'd end up with that's 0.22 moles. And then we can go ahead and convert our milliliters into liters. So that's 0.300 liters. And again, make sure you show your work. And then once we have that, then we can go ahead and do the math and complete this problem. And we should end up with, in this case, it would be a 0.73 molar solution would be your final answer. And again, that's 0.73 molar solution. And the units we use for that, again, is the capital M there, as you see. That's your units. So that would be how you go about solving for molarity. And again, we could also, you could be told what the molarity is and be asked to solve for liters of solution, or asked to solve for how many moles of solute you have. So you could have one of the others missing as well. So that's another example. So that's molarity. And again, it's pretty simple as long as you know what the equation is. The next one, you're going to have to be careful here, because this next one sounds a lot like molarity, and sometimes people mix these two up. It is another measure of concentration, but this one is measuring something slightly different. So this is our third measure of concentration, and the last one we're going to talk about today, and it is called molality. Okay, so there's molarity and then there's molality. I don't know who the knucklehead was who came up with and decided to have two measures of concentration that are almost exactly the same and that are easy to mistake. This one we represent with a lowercase m. So molarity with an R is represented, its unit is a capital M. Molality is represented with a lowercase m. That is a key thing to remember. And it starts off almost exactly the same as molarity. It's moles of solute. So we're measuring solute, the amount of solute, in this case the amount in moles. And we're dividing it, but this time you'll notice the difference is we're going by kilograms of solvent. So that's a key thing. We're not doing solution this time on the bottom. We're comparing solute to solvent. So that is something important to understand and to be aware of. And also notice that we're doing kilograms. And often in a lab situation is you measure things in grams, and so you may have to convert from grams into kilograms. So let's take a look at our first problem here. And we have what is the molality of a solution which has 0.35 moles of solute dissolved in 400 grams of solvent? And so you have molality equals moles of solute over kilograms of solvent. You write your equation down, and then you have to see, is that what I'm given? We'll start off here. Well, I am told my moles. I have 0.35 moles of solute. So I can go ahead and plug that in. I don't have to convert. You always want to check and see, is that what you're given? Because it could be they give you grams of solute, and you would have to convert from grams of solute to moles. But in this case, you don't have to. It's already told. You're only told that you have 0.35 moles of solute. And then the second thing you're looking for is kilograms of solvent. So am I told my solvent? Yes, I am, except I'm told grams. You'll notice right up here, you have 400 grams, not kilograms. So we're going to have to come over here and convert. So we have 400, and this is very similar to converting milliliters into liters. You have 400 grams. I don't want to be in grams, so what am I going to do? Multiply by a fraction. Grams is on the bottom. Why? Because I want to get out of it, get rid of those. I want to get into kilograms, so kilograms up top here. And then which one is larger? Kilograms is larger, and 1 kilogram, how many grams are there? There are 1,000. And so if you didn't remember that from before, there you go. There's your refresher course. And so then I'm going to do my math. 400 times 1 is 400 divided by 1,000. And so we end up with 0.400 kilograms is what we have on the bottom. And again, anytime you're going from grams into kilograms, you're going to divide by 1,000. And so from there, then we can go ahead and complete our math. And we end up with an answer of 0.88 molal solution. And again, the unit that you would use would be a lowercase m. So it would be 0.88 and then a lowercase m next to it. And that would mean a 0.88 molal solution. And that would be how you do molality. So it's very similar to molarity. The only difference is kind of what's on bottom, and that is instead of liters of solution, you have kilograms of solvent. And that's why it's important to know and memorize each formula so that as you come to the test, you are familiar with the formulas that you're going to be using. We're going to stop there today, and I want you to do, when you show up for class on Friday, I want you to make sure that you've done the second problem in your note packet there that I have for you regarding molality. Try to set that up and solve for it, and I will see you on Friday.